What is this? Let it be a ring. I think it not appears. So let me take a disk here or solid sphere. And this is rough. Tell me what conditions will come. Velocity of point P. We'll proceed like this. This is the velocity of point P. This is V naught. What is the tangential velocity? Tangential velocity is, oh, the same color. Huh? Tangential velocity is how much? R into 2 omega naught. I'm showing thick arrow so that will be easy for you. No, what is the direction of friction should act? The resultant velocity, how it will be? The resultant velocity will be directed Vp. Why? Because 2r omega naught will be greater than V naught. Then the friction, how it will act? Will act forward. So what is this slipping? Backward slipping you have to call. What this friction will do, will accelerate center of mass, will set up a retarding torque. Already we have seen. And after some time, it will attain pure rolling. Then again apply all the same formulas, conservation of angular momentum, and solve it. I'll write the equation directly. mv naught r plus ic into 2 omega then numerically V naught is equal to r omega naught. If you want, you can replace it. This is a pure rolling. Then what is the velocity of point P? 0. Fine. I think almost all cases I discussed here. Now let's analyze something very important part. If a body, before going for next theoretical, next idea, so let me introduce here. If a body enters, all of you do notice, it's a book's not given any much clarity. You may find very difficult to conclude anything. Now let me take a surface which is of this kind. So it is rough, then smooth, then again becomes rough. So here what happens, this body I'll give linear velocity V naught only. Tell me what will happen to it. It can happen that before attain pure rolling, this surface is rough till here. This is smooth. And this is rough. And again it will become smooth. Before attain pure rolling only, what will happen? It will enter smooth surface. What will happen to the rigid body in that region? Why the friction will act? Why omega will come? Because the friction will act in this direction. This friction, what it will increase the angular velocity, it will produce torque about center of mass, and due to that there will be angular acceleration, and angular velocity keeps on decreasing, and linear velocity decreases. If I check it, the conditions, V1 is greater than of, so forward slipping. Now what's happening? It will enter the smooth surface with forward slipping. What will happen to the rigid body in this region? What will happen to the rigid body in this region? It will continue its forward slipping. Why? Because what are the forces that are acting? The forces that are acting is normal contact and the weight. What is the net torque about center of mass? 0. Net force on center of mass, 0. So it will continue its uniform velocity motion, both rotational, translatory. With forward slipping only, it will move in the smooth surface. The moment it enters here, what conditions will arise is it is having forward slipping and V1 greater than R omega 1. So what is the velocity of point of contact? Will be towards right. So how the friction will act? The friction will act towards left. This friction, what it does? It will decrease linear velocity, increase angular velocity. After some time, it will do attain pure rolling. Let's assume. No. With pure rolling, it will again enter the smooth surface. What will happen to this pure rolling? It will continue because net torque, net all are zero. How long? As long as the smooth surface is there. Again, it will enter rough surface. Nothing will happen. Again, it enters rough surface. So the pure rolling will continue. Getting this one? So now, in the smooth surface, with what conditions it will enter the smooth surface, that conditions will be retained in the smooth surface here. If a rigid body enters with forward slipping into smooth surface, that forward slipping will be retained. If it enters here with pure rolling, the pure rolling will be retained. And if I bring it here rough again I'll make it rough. So here what will happen to rigid body? It will attain again, it will move with here pure rolling only. These are very important ideas. So tell me all together, if a rigid body enters the smooth surface with forward slipping, it will retain that forward slipping. If a rigid body enters the rough surface with forward slipping, what that rough surface will do? Will make the body to attain pure rolling. Then again, if a rigid body enters the pure rolling, if smooth surface with pure rolling, that pure rolling will be retained. Again, if the rigid body with pure rolling enters the rough surface, the pure rolling will be retained. This is about for the forward slipping. Let me give the backward slipping and release it. Then we'll see what conditions will arise. There's a very important discussion is what I'm just concluding. Now what I do, I'll give only angular velocity, or it is given only spin. So in what direction the friction will act? Because velocity of point P is backward. Then this is the, by the time just about to enter the smooth surface, it will acquire some velocity and angular velocity. When I go and check it now, still I see velocity of point P like this. There is a backward slipping and the friction will be acting in this direction. Now it will enter the smooth surface. Now what will happen? Still the backward slipping will be retained. So here V1 less than R omega 1. Backward slipping. This is smooth. This is rough. And now what will happen to this backward slipping? It will be retained. And now it will enter the rough surface. So the moment it enters here, I'm just drawing mini diagrams so that what you are studying you'll understand clearly. So how the friction will act, and the velocity of point P will be backward. Then finally it will attain pure rolling here. What will happen to in the smooth surface? This is rough. If with pure rolling enters smooth surface, it will retain that pure rolling. With pure rolling, again it enters rough surface. It will retain that pure rolling. What is the conclusion? I think you have everything in front of you now. If a rigid body, with what state it enters smooth surface, it will retain that state. Got it? Now, if a rigid body enters the rough surface with backward slipping, then what the rough surface will do will make it to attain pure rolling. If a rigid body enters the rough surface with forward slipping, then what the rough surface will do will make the body to attain pure rolling. If a rigid body enters the rough surface with pure rolling, the pure rolling will be retained. So what this rough surface will support? Pure rolling. Whatever conditions arise, it will see that it will act so that the body will attain pure rolling. That is a basic core idea. Some of you are asking, sir, way to way rough surface. Huh? Okay, then I think I'm giving some clear boundary, rough and smooth. Net torque, net force is zero. There's no any other torque. Go back to the basics. What is the net force here?